Now the 15-volt sense drives directly into the base of Q1466B, where it compares against a divider composed of R1463 and R1464, which is tied to the minus 50-volt sense as a reference. Now that places the base of the A side of that transistor at precisely minus 15 volts. Any error occurs amplified and inverted across R1480 to drive into the base of PNP transistor Q1485. Now there it's inverted once again, taken across collector load resistor R1487 to drive into the base of current amplifier Q1496, which in turn drives series regulator Q1498. Now this is a negative supply, so maybe we ought to go through the operation of this one. An increased current requirement would cause the minus 15-volt supply to go less negative, or in a positive direction. Okay, the base of Q1466B would go in a positive direction. Its collector then would come down, biasing Q1485 to greater conduction. Its collector would come up. That would bias Q1496 to greater conduction, which in turn biases Q1498 to greater conduction, thereby increasing the current to satisfy the requirement of the increased load and maintaining the minus 15-volt sense at a constant potential. The overload sense resistor is R1498. Quiescently, Q1489B is on, Q1489A is off. Now when overload current occurs, and we drop the base of Q1489B, you see an increased voltage drop across R1498. Q1489B turns off, Q1489A turns on. As it drops the emitter of Q1485, the transistor draws less current, its collector drops, dropping the base of Q1496, which in turn drops the base of Q1498, reducing the current out of the regulator. Now to the left of Q1485 are two diodes, CR1482 and CR1483, and under normal operating conditions, they're zero biased. Now let's establish the level at the top of those diodes. Follow off to the left and you'll see that that level is set by VR1461 to 5.1 volts. Now let's follow that off to the right then to CR1489. Now we're up a junction through that diode. Off to the left we're down a junction to the base of Q1485. So the base of Q1485 sets at 5.1 volts, and both of those diodes are zero biased. Now CR1482 protects the base emitter junction of Q1485 in case Q1466B turns off. See, under that condition, the collector of that transistor would go up towards plus 17 volts and damage the base emitter junction of Q1485. Now Q1483 catches the base of Q1485 when in overload we're trying to turn that transistor off by dropping its emitter. R1495 and C1495 is that slow-down circuit to keep this thing from oscillating. Notice down there by the error comparator we have two protective diodes. CR1468 protects the base emitter junction of Q1466B in case we lose the minus 50 volt supply. You see, under that condition, the base of Q1466A would go up to ground. Its emitter would follow it up. Now that would lift the emitter of Q1466B, of course, above its base and damage that junction were it not for CR1468. CR1469 protects the base emitter junction of the A side of the transistor in case we lose the minus 15 volt supply. Well, let's drop down to the minus 50 volt supply next. As we said earlier, this is the reference supply for all of the rest of them. Let's begin to the left of the error comparator with VR 1505. Now that's a 9-volt Zener and is a reference for this supply, which in turn is reference for all others. Now that Zener sets the base at Q1508A at a minus 9 volts. Over to the right there, the error divider composed of R1512, the minus 50 volt adjust, and R1514 to the minus 50 volt sense, sets the base of Q1508B at minus 9 volts. All right, any error then appears amplified and inverted across collector load resistor R1517, which drives into the base of Q1522, where it's amplified and inverted again, and drives into current amplifier Q1534, which in turn drives the series regulator. Now this supply also uses that 5.1 volts established by VR 1461, that 5.1 volt Zener up above there. Now that's used as collector supply for Q1508A. And if you follow off to the right, CR1523 places the emitter of Q1522-1 junction above that 5.1. We're down a junction to the base of that transistor, so protective diodes CR1520 and CR1521 are zero biased as in the minus 15 volt supply up above. They protect in the same manner. A single transistor, Q1526, provides the overload protection. R1537 is the overload sense resistor. As soon as we draw enough current and to pull down on the emitter of Q1526, it'll turn that transistor on. As this collector pulls down, it disconnects CR1523, reduces the current through Q1522, which in turn reduces the drive to Q1534, and that reduces the current through Q1538. R1531 and R1529 forms the divider which provides the fold-back feature. Now let's go back down to the error divider, Q1508A and B. Its emitter returns down through CR1503 to minus 50 volts. Well, you can't get the regulator to work without the minus 50 volts. You don't get the minus 50 volts until the regulator works. So how do we get it started? Well, that's the function of the start circuit off to the left there with VR1501 and CR1502. Now that's tied to a minus 54 volts pre-regulated. Now by the time we drop through that Zener and through the diode, the emitter supply is 47.1 volts. And that supplies the emitter current for the comparator, gets the regulator going. As soon as the minus 50 volt supply comes up, or down I guess we should say, we pull down through CR1503, disconnect CR1502, and the minus 50 volts supplies the emitter current for the comparator. CR1510 protects the base emitter junction of Q1508A in case we lose the minus 50 volt supply. See, under that condition, the B side of that comparator would go to ground. The A side would be pulled down to a minus 9 volts through the start circuit. Now, CR1506 appears to do the same thing, apparently as a redundant diode and was left over from an earlier design. Okay, the next and the last regulator is the plus 5 volt supply. Now we won't need to discuss that. It's almost identical to the plus 15 volt supply. Now just to the left is the graticule illumination circuit. Now we use current from the plus 7 volt pre-regulated supply, which passes through Q1550 to power the graticule lights. Now, why use an elaborate circuit like this rather than just a wire-wound pot? Well, it's cheaper than a wire-wound pot, for one thing. It's more dependable, and it provides short protection. Now, the graticule illumination control can swing the base of Q1546 from 0 volts to 6.2 volts. The emitter of that transistor returns through an equivalent 220 ohms or so to a minus 570 millivolts. Now, as we vary the graticule illumination control, we vary the current through Q1546, which in turn varies the current through Q1550, and that then controls the graticule lights. Now, we have a couple of diodes, CR1549 and CR1543, and they're tied right across R1551. Yes, that's a third of an ohm resistor. Now, in order to establish the levels, let's start at the collector of Q1550, call that reference. Now we're down a junction through CR1549, up a junction to the base of Q1546. We're back to the reference level again. Then down a junction through CR1543. Now, CR1549 is going to be on all the time, but in order for CR1543 to be on, we'd have to have a 600 millivolt drop across R1551. Well, that would take 1.8 amps in order to do that. Well, these graticule lights are only 200 mil lights, so it would take a short in order to provide the 1.8 amps to provide the 600 millivolts drop across R1551 to turn on CR1543. Well, when that happens, then we pull down on the base of Q1546, reducing the current through that transistor, which in turn reduces the current through Q1550 to a safe level. Well, that concludes the low voltage regulators and the instrument. This has been a detailed circuit description of the Tektronix 7904 oscilloscope. This has been Chuck Miller.